Alright, CNT125, we're looking at Chapter 8 on subnets and VLANs. In this chapter, we want to look at network segmentation. Two big ways we segment networks is through subnets and VLANs, so this kind of all fits together. This is an important foundation topic for network design, using subnets and VLANs in designing our network. So really good, really important information in this chapter. Now, before we dig into those topics, this first podcast, we're going to remember what we learned in 120, Chapter 3 and 120, on addressing. So this first podcast is going to try to refresh your memory on a bunch of these things we should already know or remember. IP version 4 addresses, 32-bit addresses, 2 to the 32 possible IP addresses, 4.3 times 10 to the 9 addresses, really a finite number. By today's standards, we have actually run out of IP version 4 addresses. IP version 6 address is 128 bits. There you have 2 to the 128 possible IP addresses, or 3.4 times 10 to the 38. We should not run out of those anytime soon. Hence one of the reasons we're migrating to IP6 as the time goes on. Remember your binary conversions. I do have our 120 binary conversion or number conversion podcast linked in D2L for you in case you need to remember that. Foundation topic for a lot of what we're going to do on subnetting. Review that if you need to. IP version 4 address is 32-bit address. It's organized in 4 groups of 8 bits. Each 8-bit group is called an octet. That gives us 4 decimal numbers in the IP address. Each of these octets can range in decimal number from 0 to 255. So if we take a look, I think I have a sample here on the next page. Here you go. Here's a sample IP version 4 address. There's your 4 octets. Number, dot, number, dot, number, dot, number. That is a standard format for IP version 4 address. And again, each of these octets is 8 bits. And those 8 bits can represent numbers from 0 to 255. If I take a look at it here, this number 192.168.10.48 actually looks like this in binary right here. This is actually what computers and networks see as data is moving around. The decimal up here is really for us humans to see. But that's down here is what the networks see. Hence the reason there are times we're going to work with these numbers in binary because of that. If I do a ifconfig on something like my MacBook, up here's the command ifconfig that allows me to see my current IP address that my machine is using. If I do an ipconfig on a Windows machine, I can actually see the currently used IP address on my Windows machine. Okay. IP version 4 addresses, when they were created, were set up to be classed. I should say classes of addresses, class A, B, C, D, and E. IANA set this structure up that depending on the type of organization requesting an IP address to have things attached to the internet, if you will, they were allocated either a class A, B, or C address. So, for that, class A, the first octet was indicated or designated by IANA. Class B, the first 2 octets were. Class C, the first 3 octets were. Class D and E, D was set aside for multicasting, E set aside for research. So we need to remember those classes because that plays a lot into how we deal with the numbers that we're using in a network. Class A address then, the first octet is dictated by IANA as the network portion that identifies the network. The remaining 3 octets are left alone, or those are free for the admin to assign to nodes or devices in the network. So those are host portion octets. This Class A addresses were traditionally set aside for government use. As I like to say, government's use, because there is more governments on the planet than the government that we're currently sitting in here in the United States. There's more governments in the world. So with this one, you have basically 24 addresses at your disposal, so roughly 16 million host addresses can be on a Class A network. Hence why that is set aside for governments. Example of a Class A network would be 50,000. The first octet for a Class A is from 1 to 126. First octet for Class A is 1 to 126. Make sure you know that range. Class B, The first 2 octets were dictated by Anna, as I like to say, carved into stone, if you will. The remaining 2 octets were left alone for the network admin to assign to nodes in the network. So these were traditionally set aside for large businesses, global businesses or businesses scattered around multiple continents, if you will. So this one, there's two octets left for host, these last 2 here, giving us 16 bits for host. So 2 to the 16 gives us the ability to have 65,000 addresses for nodes, computers, printers on a network. Hence why this was set aside for large business. Here would be an example of a Class B network address, 185.96. Class B addresses, first octet is 128 to 191. Again, make sure you know that range. And also remember 126 up here. 126, 127, that 127 is not left out on purpose. 127.001 is your loop back. So the 127 is not allocated to networks for that reason. Class C then is, IANA dictated the first 3 octets as network. The remaining octet is host. So in this case, IANA gave you or dictated to you the first 3 octets. The remaining octet was left alone for the admin to assign to nodes, devices, printers, etc. on a network. So with that one, there's only 8 bits left. 2 to the 8 gives you 254 possible host addresses or 254 possible IP addresses to assign to computers, printers, phones, that sort of thing on a network. So these were set aside for everybody else. Class C addresses were set aside for everybody else. Here would be a sample Class C network number, 210.32.67.0. Class C addresses first octet, 192 to 223. Again, make sure you know these first octets. As you look at an address, that is your clue as to what you're working with, Class A, B, or C. That's your clue. Important. Class D was set aside for multicasting. First octet for Class D is in the range of 224 to 239. And you actually did already see this with your routing lab because OSPF used multicasting to send routing updates. So that should be somewhat familiar to you, or you should recognize that. So if you see a number in the 224 to 239 range, you know that's a type of multicast for whether an update or a special protocol kind of thing. Class E was set aside for experimental use, research if you will, 240 to 254. Remember, as I deal with those 8 bits in an octet, I have 256 combinations of numbers. 0 the whole way up to 255 is 256 numbers. 0 is always kind of set aside as identifying the network. Remember that. And 255 is almost always set aside for broadcast. So hence we end up with the 254 usable numbers in there. 254 usable numbers in there. Stick that in the back of your brain for now. And I also put down here a reminder, don't forget 127.001 is reserved for loopback or testing. This is one of the graphics that books often show you, showing you Class A, the first 8 bits up here is for network, the remaining 24 host. Class B, first 16, remaining 16 for host. Class C, the first 24 is for network, the remaining 8 is for host. So that's just kind of showing the breakdown. Same thing with this guy down here. Okay. And then this up here is reminding you of your first octet, 1 to 126, 128 to 191, and so forth. Okay, so just whatever pictures are going to help you recognize that. Here's what I said earlier, 000, 0 is usually your network number, 255 is your broadcast, 127.001 is loopback. Okay, again, all those pieces, make sure you remember all those pieces. The second piece on this is your subnet mask. Don't forget your subnet mask is kind of like your IP address decoder, for lack of a better term. Your subnet mask is a 32-bit number identifying what portion of the IP address is network, what portion is subnet, if there is any, and which portion is host. That is a key to know whether anything special has been going on in that network. So your network and host portion is represented by all ones. Your network and subnet portion, network and subnet portion, I apologize if I said something different there, is represented by all ones. The host portion is represented by all zeros. Okay? So that becomes important as we start looking at the subnet mask to know what's going on. The subnet mask is always used in conjunction with the IP address because, again, that's informing the devices in the network, router switches, workstations, and including us, the admins, which part of the address is network, which part of the address is host. Okay, and that's typically represented a dotted decimal notation. Class A address, as we said before, the first octet was network, so the default subnet mask is going to be 255.0.0.0. The first octet was network, so it's all ones. So all ones in that first octet is going to yield 255. The remaining 3 octets being host are going to be 000. Class B, first two octets were network, so 255.255. Remaining 2 octets are host, so 00. And then Class C, first 3 octets are network. Remaining octet is host, so we have 255.255.255.0. That is the default or normal subnet masks. Well, let's take a look at an example of a Class A. Here would be a Class A IP address. The default Class A subnet mask, 255.0.0.0. If I were to see this IP, 110.50.32.72, with a subnet mask of blah, 255.224, there's a red flag. We know some kind of subnetting has occurred because 224 is actually 111 followed by 5 zeros. So we see ones in this portion here that normally are not there. We know some kind of subnetting has occurred. Same thing on Class B. I normally expect 255.255.0.0. If I see right here 255.255.240, I know some type of subnetting has occurred. Class C, I see a 210 and a 255.255.255.0. But if I see a 210 and then I see 255.255.255.248, again, I know some kind of subnetting has occurred. And we'll work our way to that. Don't forget your public and private addresses. Public are the ones assigned by AANA. Private would be the numbers we can use on our own network. We are perfectly allowed to use. And these are the private ranges we can use inside of our network, 10, 172, or 192. Kind of like an A, B, and C, if you will, that kind of gist. Those are the private numbers set aside for internal use on our network. Don't forget those number ranges as well. Don't forget your PIPA addressing, 169.254. That was your automatically privately assigned IP addressing. If a computer boots up and cannot find a DHCP server, it self-assigns a 169.254. Set that number aside as well. Okay, and that's basically what this is reminding here. That's in a PIPA type address, a 169.254. Remember unicast, multicast, broadcast. Unicast is a message going to a specific node. So going to a 192.168.52.23, going to a specific node. Broadcast would have ones, a series of all ones, like this guy right here, going to everybody. Or it might have something like 192.168.10.255, meaning that network, everybody in that network is going to get that message. Okay? And then don't forget the multicast in the middle. A 224 address is indicating multicasting. And certain protocols use that to get a message to a group of people, just like your OSPF in your router lab. Just like the OSPF in your router lab. Alrighty, so get all that back in your brain. Remember all that from Chapter 3. Now we're going to add to that with what Chap8 is now presenting to us. I'm going to come back in the next podcast and start into the new material with you.